So if we can't test every single input, how do we choose which ones to test? Well, our first tool helps us solve this by cleverly dividing up the problem. Let's talk about equivalence partitioning. The idea here is actually pretty simple, but it is so powerful. We take all the possible inputs, and we divide them into groups, or what we call classes. The theory is that the system is going to handle every single value inside one of those classes in the exact same way. So if that's true, we don't need to test 100 different values from one class, we just need to pick one. And just like that, you've massively reduced the number of test cases you have to write.
Okay, let's make this super practical. Imagine a username field, and the rule is it has to be between 3 and 20 characters long. Using this technique, we can spot 3 classes right away. First, there's the valid class, any username that's 3 to 20 characters. So we pick one, like tester123, to represent that whole group. Then we have 2 invalid classes, one for usernames that are too short, like AB, and another for ones that are too long. By testing just one value from each of these 3 partitions, we've basically covered the core logic for this entire rule. Way more efficient, right?
Now, equivalence partitioning is a fantastic start, but it has a partner that makes it even more powerful. This next tool helps us zoom in on the specific areas where bugs just love to hide.
This quote from the testing legend Boris Beiser says it all perfectly. You see, developers often make tiny mistakes, we call them off-by-one errors. Maybe they used a less than sign when they should have used less than or equal to. And those kinds of bugs, they almost always pop up right at the edges, the boundaries between our partitions.
So this brings us to boundary value analysis, or BVA. It's a technique designed specifically to attack those high-risk edges. Instead of picking a random value from the middle of a partition, we get really specific and choose values that are right on the boundary and just on either side of it.
Let's go right back to our username example. The valid range is 3 to 20. BVA tells us, hey, don't just test any number. It tells us to test these exact values. 2, which should fail, 3, which is the very first valid number, 20, the very last valid number, and 21, which should fail. Trust me, these 4 test cases are way more likely to find a bug than just testing random values like 10 or 15. So here's the pro move. Use equivalence partitioning to find your classes, and then use BVA to pick the absolute best test values.